Okay, so we're going to get started here. I do want to remind you that today we are focusing in, as you guys can see, on multiple choice. Oops, turn my sound off. So we're focusing in on multiple choice. So this is really you guys driven. It's really based on whatever questions you have. Also, don't forget that tomorrow will be, make sure that you have finished up the free response question. It's the second slope field one. I don't remember what number that is, but make sure that's finished up. And then, of course, we can go through questions that you had in regards to, I can't remember. We talked about it yesterday. So I said we'd go over something yesterday. I can't remember which problem it was. So anyway, let's start with questions that you have for today. So again, make sure that if you're going to be asking questions, you can either ask it in the general voice channel, or you can ask it in the calculus questions and information channel, or of course you can ask it on the live stream itself. So again, this is based on you guys. I don't have any set plan here in terms of problems I want to go over. It's all based on what you think you're having difficulty with. So again, ask away. Okay, so first one, number 12, how do you figure out the domain? Let's go from there. Let's see what we got. So which of the following is the solution to the differential equation? Which of the following is the solution to the differential equation blank, where y is -1 equals 1? Okay, so let's kind of look at let's kind of quickly go through and solve it, and then we can kind of talk about the domain a little bit. So in this case, I think you guys would agree, and I think I have room here. Let's see. Let's hope I have room here. So I'm going to say dy equals dy divided by y squared. Actually, let's, just to save room, I'm going to say y to the -2 dy equals dx. So this becomes -1 over y equals x plus c. Okay, so when we go to solve this, so first off, let's quickly go through and um, solve this. So first off, they say when y equals -1, this thing equals 1. So if we were to plug in, I can do it right off the bat right now, so I might as well. Let's plug in -1 for x. So it's y of -1. So we get -1 over y equals -x plus c, except we can replace that y with 1. So this is -1 equals -x. Let's see. -x. Actually, I'm sorry. I don't know why I'm doing -x. Let me clean that up. Maybe it's a little bit too early to start here. So let's put in the numbers correctly. So we're plugging in plugging in the point -1, 1. So I get -1 over 1 equals -1 plus c. So I think you guys would agree c equals 0. So when we get at this, we get -1 over y equals x. So y is going to be equal to -1 over x. So when we talk about the domain now, we have to say, let's think about what this graph looks like. Okay, because there's a vertical asymptote. So there's two branches to this graph right here. So one of the graphs is going to look like this, and the other is going to look like this. We want the branch that is going to include the point. Did I do that wrong? If I plug in, let's double check. If I plug in 1, yeah, no, I think I'm okay here. Let's just, yeah, no, I should be okay. So when I plug, excuse me, when I plug in the point negative 1, 1, I think you guys would agree. I'm looking, whoops, didn't mean to erase. I'm looking at this branch, okay? So I'm looking at this one. So when we want to talk about the domain here, usually what we do when we talk about the domain, so it depends on the way this is written. So let's see, if it's the branch that contains that point, let's see here. If it's the branch that contains the point, so I'm sorry, I'm struggling a little bit on this. And the reason I'm struggling a little bit on this is, so I could see this going kind of two different ways. One is I think you guys would agree x cannot be equal to 0. So clearly x can't be equal to 0. So this is true. And then, but also it does have to be negative x. So we are looking at, so let's see why this one works. Because I think you guys would agree this is really our only possibility. So the reason is when we're looking at this, when we're kind of we have to kind of talk about which branch are we talking about when we do this. And okay. And actually I'm sorry, this does make sense now that I kind of go through it. The reason is we're talking about this being the original function, right? So when we talk about this being the original function, we do have to consider that the breakup. So again, it's kind of like we have two functions here, and they're asking you which of the functions fits this situation, right? Is it the top curve or is it the bottom curve? In this case, I think you guys would agree with that top curve. So that's why the domain is limited there, and that's how we determine, because it's the branch that contains that point. So when it comes down to it, you're asking yourself, okay, I'm given these different choices here. How do I know which choice is correct? You have to say, well, when I plug in my point, which of my graphs contains that point? Okay. So just to pause here, I did kind of miss a couple things here. I wasn't looking at the Discord while I was doing that kind of rambling explanation. So I did plug in, just making sure, I did plug in the point negative 1, 1, I think, right? I did plug in the point negative 1, 1. It took me a little bit. So I think that first question in Discord is asked. I was just kind of slow on the uptake there. Are there any follow-ups on that one? Does that make sense? Okay, then let's move on to number 6. Let's move on to number 6 here. What do we got? Okay, so a particle moves along a straight line with its position function given by this. What is the velocity of the particle when its acceleration is 0? So first off, as always, and I know it's kind of given here, but don't forget when you're given a function, especially when we're talking about objects and things like that, you should really ask yourself, what are we looking at? So reminder, they tend to use, in case you're ever confused, they tend to use S of t to represent a position, V of t to represent a velocity, and A of t to represent acceleration. I'm not going to say that they have to stick to that, but that's been pretty general for them. So if you're ever unsure, in this case, they did say it's position function, so it's pretty clear, but just to make sure. Okay, so let's see what we got here. A particle moves along a straight line with its position at any time t greater than 0, given by this. So what is its velocity? So in order to find the velocity, I think you guys would agree, man, I'd like a little extra room here. Maybe this was not the best place to do this. I don't know how else I could have done it, but maybe let's do this. No, that's just going to take too long. Okay. So first off, I think you guys would agree, in order to find the velocity function, I'm going to take the derivative of s. So I'm going to say the velocity function equals the derivative of s, which in this case, I think you guys would agree, by second fundamental theorem of calculus, is going to be this. Okay, that's a flashcard. Before I continue with the acceleration, is there any questions on that flashcard, the second fundamental theorem of calculus? Okay, so now let's go find the acceleration function. So I think you guys would agree the acceleration function is going to be equal to the derivative of the velocity function. So we're going to take the derivative of this. So this is going to become 1 over 2 root x, sorry, 1 over 2 root t minus 1. Okay, so next, let's see what we're supposed to do. So what is the velocity of the particle when the acceleration is 0? So now I'm going to set the acceleration equal to, I'm going to set that acceleration equal to 0. So I'm going to say 0 equals 1 over 2 root t minus 1. So what do we get? 1 equals 1 over 2 root t, and I get 2 root t equals 1, root t equals 1/2, root t, so I'm going to square both sides, root t equals 1/4. Let's just make sure the math is correct on that before I continue. So let's see. A derivative, 1 over 2 root t minus 1, that looks good. Add 1, multiply by that looks good. Divide by 2, looks good. And then square both sides, perfect. Okay, so I have found my time. So what they're really asking is, they're saying, what is the velocity? So if they're asking what is the velocity when the acceleration equals t, when the acceleration equals 0, they really want to know what is the velocity at t equals 1/4. And so I'm going to take my velocity function, which I found right here, and I'm going to plug in 1/4. So I'm going to get the square root of 1/4 minus 1/4. So it looks like 1/2 minus 1/4, which is 1/4. Okay. In regards to number 6, are there follow-up questions regarding that one? Okay, then let's keep on going. I'm going to go to number 13. Number 13. Okay, what do we got here? When the area in square units of an expanding circle is increasing twice as fast as its radius, in linear units, the radius is, okay, so let's see. When the area in square units of an expanding circle, so we're talking about the area of a circle, so I think you guys agree, we're talking, actually, let me backtrack just because I think we can do better. So when the area in square units is expanding, so we're talking about an area that's increasing. So in other words, I'm saying dA dt, right? That the area is increasing, it's changing twice as fast as its radius. So it equals 2 times the rate of change of the radius. Now, I don't know if I'm going to need this yet, but that's what that first part is saying, right? It's saying the area is increasing twice as fast as the radius in linear units. So we want to know when that is. So in order to do that, let's see. So let's see here. So in order to do this now, what I'm going to do is I'm going to go and find my area. So my function is area equals pi r squared. So I'm going to go take the derivative of my area. So I get dA dt equals 2 pi r dr dt. But what do we know? We know that dA dt equals 2 dr dt. So I can replace that right now. So I get 2 dr dt equals 2 pi dr dt. Now notice I've got a dr dt on both sides and a 2 on both sides. So what do I get? I end up with, what am I missing here? Sorry, do I have a variable? Did I drop a variable somewhere? I did drop a variable. My apologies. Let me backtrack. I dropped a variable. It looked like I dropped it. That was kind of silly. Why didn't that erase? Okay, let me take the derivative correctly since I took the derivative incorrectly. So dA dt equals 2 pi r dr dt. I think I dropped that r. So then replacing the dA dt, I get 2 dA dt equals 2 pi r dr dt. But of course, we notice that there's a 2a dt. Sorry, man, I'm having troubles today. Pausing just for a second, I replace the dA dt with 2 dr dt, as we said up here. Now, I'm going to cancel out the things that are on both sides. So I'm left with 1 equals pi r. So 1 over pi has to equal r. Okay? I know that I was a little that went a little bit poorly. So let's just make sure that we're good on that one. So let's see. I don't understand how you use implicit. That's a different question. How did you know it wasn't a area equals 2r? Oh, so remember area equals 2r. Oh, in terms, so just to make sure, I'm assuming that we're talking about up here. How did I know that? The reason is they said when the area of the square is expanding. Expanding means rate of change, right? So it's not a position. It's not saying when the area is twice as big as the radius. It's saying when it's expanding twice as fast as the radius. So that's a rate of change. Okay. In regards to number 13 that I kind of butchered a little bit, do you have any other follow-ups? Anything I need to clear up? Okay, then let's look at number 15. Uh-oh. I think I may need to grab this and move it over. I really feel like I'm not gonna have the room to do this here. I might. I mean, I could be completely wrong and maybe it's a really short problem. But let me just, I'm gonna do it on a separate one, a separate sheet, because I'm a little concerned. Let's see. What are we saying? The slope of the tangent line is to the curve, this curve. So let's make sure I copy it down, 3xy. So y cubed equals 2 at the point x equals 1. Okay, so let's go find out what that is. So let's go do that on a clean one where I have plenty of room. So if I copy anything down wrong, please let me know I did it. I'm doing it from a separate thing here. So 2x cubed plus 3xy plus y cubed equals 2. And we are asked to find, is it the equation of the tangent line or just the slope of the tangent line? Let me check really quickly. I kind of forgot what they're asking. The slope of the tangent line to the curve. Okay. Okay, so I think you guys agree. The first thing we are going to do is we're just going to go through and take the derivative. So let's go and do that. So when I go to take the derivative, I get, this is with respect to x, so I get 6x squared plus 3. Now, this is a product, so the derivative of x is 1. 1 times y is y, plus x times the derivative of y, which is y prime, and that's plus 3y squared, y prime equals 0. So before I finish up, before I continue, because I'm going to have to solve for y prime here, are there any questions on the derivative? And I should, of course, double check that I took it correctly. It looks good to me, I think. 3y squared y prime. Yeah, looks good. So the question was, how is it in terms of x? Usually when we do these functions, they're always in terms of x. If you think about it, they're just giving a function. I mean, technically, they didn't tell us, but it's going to be in terms of x. Whenever they give you a function like this, you can assume, unless they tell you otherwise, you can assume the function's in terms of x. BC, x equals 1. Oh, you mean because? I'm assuming shorthand terms that old people like myself don't know. It's, well, it's not really because it's not really because x equals 1. Mike, I think, and I could be wrong, I think we could do this with respect to y. Now, whether we could solve it with respect to y or not, I think we could do this with respect to y and still get the same answer. I think it doesn't technically matter. Again, I have to double check it. It's been a long time since I've done like something like that. But usually just on a general note, because we don't on an AP test, you don't have time to play with it. Unless they tell you to take something with respect to y, or unless the function, right, like we have some sort of function where um, it's in terms of y. So, maybe we're doing some sort of, I don't know, related rate problem, or what did we just do? We did graphing, maybe some sort of graphing problem we're doing with respect to y. Usually you're going to take things, if it's a mix of x's and y's, you're going to be doing with respect to x. Okay, unless, like I said, unless they go out of their way to tell you otherwise, it's with respect to x. Okay, but again, you should be able to do it both ways. But again, it will be usually it'll be harder one way or the other. So let's keep on going here. I say you should be able to do it both ways, but I'd have to actually prove that. I'm not completely positive on that, but I'm like 90% sure on that. Okay, so let's go solve for, I dropped something. That's a y prime. Let's go solve for y prime. So I get 3x y prime plus 3y squared y prime equals negative 6x minus 3y. And we get y prime times 3x plus 3y squared equals this stuff. So we get y prime equals this stuff divided by this stuff. Now, the other thing we need to do in order to finish this one up, right, is we have to know what x and y is. We know what x is, but we don't know what y is. So in order to find out what x is, I'm going to take my original function, this one right here, and I'm going to plug in 1 and solve for x. So let's see what we get here. I'm going to do this in red. So we get 2 times 1 cubed, which is 2, plus 3 times 1, which is 3, times y, plus y cubed, which we have no idea what that is, equals 2. So let's see, we get 3y cubed, sorry, 3y times 3y cubed equals 0. So from here, I'm going to pull out a y, so I get y equals 3 plus y squared. So I think you guys would agree there's only one solution. Y has to be equal to 0, since 3 plus y squared can't be equal to 0. So in this case, for my final answer, and of course, because it's multiple choice, I'd have to simplify it, but I'm going to be lazy and not. I'm going to say this is negative 6 times 1 minus 3 times 0 over 3 times 1 plus 3 times 0 squared, and I can simplify that. So the question is, what are you doing in the red? In the red, I was taking this value right here, x equals 1, and I was plugging it into the position function just so I could figure out what point. Notice when I took this right here, in order to evaluate y prime, I needed to know what x is and y. I didn't know what y is because all they told me was x equals 1. So I had to use the x equals 1. I had to plug the 1 into the position function in order to answer that. Okay? Is there follow-ups on that? Does that make sense? Again, I just plugged in 1 in order to figure out what point this is. So this is we now know from the red, I now know this is the point 1, 0, and I can plug 1, 0 into there. Isn't it negative 6x squared? Negative 6x squared. Negative 6x squared. Where are you looking? Oh, you are right. I did copy that down wrong. You are correct. Yes, it is. I just didn't, I made a careless error there. Okay. Any follow-ups on that one? Does that make sense? Again, I took the function implicitly. Then once I solved for y prime, I needed to know what the point was. So in order to find the point, I just plugged in x, plugged in y. Yes. So the question is in red, are you plugging it into the position function? And the answer is yes. I'm plugging 1 into the position function in order to find the y value. That's exactly what I'm doing. Other questions first off, before we move on from number 15, are there any other follow-ups for number 15? I'll give you guys like 5 seconds or so just to Deal with the lag. Where'd my coffee cup go? Okay, let's see here. Can we do, I think we did number 13. We did number 6. We did number 12. Are there other questions from the multiple choice packet? I think I've done, unless I've missed something. So if I missed something, please let me know. But I think I've done all the questions you've asked so far. So what other questions do you have? Oh, there's a few coming in. Oh, there's my coffee cup. Let's take care of, okay, a few numbers coming in. Perfect. First off, let's just take care of, is there something wrong or is it on my end? I don't know. So maybe could you tell me what's wrong? Or I guess ask chat because I don't know. I think it's working for me. I don't see any issues. But then again, I don't have sound on because it really causes the problem. So is there anyone else experiencing any problems with the stream just before I move on? Okay, so just to kind of warn you guys, I had trouble. If you were on early, you may have noticed that the stream kind of started and stopped, started and stopped. I was having difficulty today, so it would not surprise me if this thing is having issues or if it breaks down. So you do need to let me know because again, I was definitely having issues. I was actually almost worried that I wasn't gonna be able to do it today. So let's keep on going here. Um, what do we got? So could we do? I'll start with number 25. Just kind of go in order here. Okay, so just to be kind of clear, number 25 is that's a calculator question, which is fine. It is, but it is a calculator question. So we just kind of need to recognize I wasn't really asking for this set yet. I was really just asking for the non-calculator stuff. But let's kind of go through it. Let's see what we can do. Um, so we got this. Actually, you know what? If you guys don't mind, I know I want to hold off on the calculator stuff, and the only reason I want to hold off on the calculator stuff for now is I've only asked for the non-calculator stuff. So I want to give. Um, is this no calculator? Wait. Oh, I'm sorry. I thought this was. I was my. Oh, I was looking at the wrong part. I'm sorry. Okay, you're fine. You're right. I'm wrong. That was just me being wrong. Okay. So let's see what we can do here. Um, okay, I'm hoping I don't need more room on here. I'm a little concerned. Let's see. Okay, so we got a function that's f is continuous on the closed interval from 0 to 9 and has the given value on the table. Um, the trapezoidal approximation with found with 3 subintervals indicated by the data in the table is 57. What is the value of k? Okay, so what I'm going to do with this one is I'm going to set this up. In other words, I'm going to take this thing right here, and I'm going to just evaluate it like I normally would, right? So if this was a free response question, I'm going to go and evaluate it. So let's see what it would be if it was a free response question. So we'd say, okay, well, this thing would equal, and if you don't mind, I'm going to do this down here. It's going to be equal to 1/2 the average of the bases. So k plus 3 times the distance between those, times the height, which is 4, plus the average of the next bases, so 1/2, 9 plus k, times, what is that, 3, plus 1/2, 11 plus 9, times 2, and this whole thing is going to equal 57, okay, because they told us it equals 57. In regards to the setup, do you have any questions? Right? I'm just doing this thing like I'm normally done. They told me to find trapezoids. I'm finding trapezoids, and I'm setting them equal to 57. At this point, if you notice, I should be able to solve for k pretty easily, right? This is just a one variable equation, so I can solve for k. I'm not going to finish up the solving for k because, like I said, you should be able to do that. But do you have any follow-ups? Are there any follow-up questions on that one? Because I know 25 does get asked a bit. No? Okay, then let's see what we got here. Let's look at number two. Oh, is there a question? Okay, number 20 is coming in. So let's see, what do we got? Or number 20 was asked. Okay, the y-intercept for the tangent line to the graph, blank. Okay, so let's see what we're gonna do. So they want to know what the y-intercept is. So in other words, really what the question's asking me is write the equation of the line for the tangent line to this curve, and then tell me what that y-intercept is. Okay, so let's do that. So in order to write the equation of a tangent line, I think you guys would agree, I'm going to need two things. I'm going to need a point and a slope. Let's start with the point. So in order to find the point, I recognize the x-coordinate is e. So what I'm going to say is y of e. I'm just going to evaluate the position function at e. So I get e squared times the natural log of e. The natural log of e is 1. So this thing is just going to be e squared. So the point that this thing is going to go through is e squared. I'm on 21. I'm doing the wrong one. Um, yeah, no, I'm definitely doing the wrong one there. Just to follow up, is there anyone who had a question on 21? I was doing the wrong one. Nobody asked anything about 21. So if you don't have a question on 21, then I will just go back and do number 20. That was my fault. Okay, then let's see here. Okay, so 20, okay, let's finish up 21 then. Okay, so here we are, we've got the point. Now I need a slope. So in order to find the slope, I think you guys would agree. I'm going to do it underneath 22 just because there's plenty of room. So in order to find the slope, I'm going to take the derivative of this function. So this is a product rule. So I'm going to get 2x times the natural log of x plus x squared times 1 over x. Let's just make sure that that is correct. So take the derivative first. That's 2x times natural log of x. That's good. Plus, yes, that looks good. Cleaning this up, I'm going to clean this up a little bit because I think it's going to make the math easier. So this would be plus x. Okay, so now what am I going to do? I want to find that slope, so I'm going to evaluate it at e. So I'm going to take y prime, evaluate it at e, and I get 2e. The natural log of e, as we already know, is 1 plus e. So I have 2e plus e, which is 3e. So the equation of my line is going to have a lot of e's in it, but my equation of my line is going to be 1 minus e squared equals 3e times x minus e, and then I can solve that. I can solve that for y and simplify it. Okay. Any other question? Before I finish up number 21, is there any follow-ups on that one? And then we'll go to number 20. Okay, let's move on to number 20. I'm going to get, let's see what we got here. Okay, let's move on to 20. I don't know how much room I'm going to need. So the function f is continuous at x equals 1. Okay. Probably asking then then what is k? So here's how we're going to find what k is. In order to find k, I'm going to take the limit of this function, because if this thing is continuous, this thing as a whole, at x equals 1, there has to be some, I'll come back to, okay, so just before there was a follow-up on number 21. Let me finish up the follow-up on number 21 really quickly. The follow-up on number 21 is, weren't we supposed to find the y-intercept? Yes, we were. So what you're going to do is you're going to take, again, I didn't finish it, but you guys should be able to finish it. I'm just going to take this thing and put it in y equals mx plus b form. Whatever the b is, that's my y-intercept. Okay? So you guys can do that. So let's go back to number 20. So again, what I'm going to do, if I take this function right here, they're telling me that the function is continuous at 1. But I can look at it and say, no, if I plug in 1, there's an issue. I think you guys would agree. When I plug in 1, there's clearly an issue. But they're saying there isn't. So that tells me there's some sort of hole there. So what I'm going to do is I'm going to find the limit. I'm going to say, what should that value be? If I take the limit from the left and the right, what is it going to? So let's see what we got here. And I think I have the room to do this. So if you guys don't mind, I'm going to take the limit as this thing approaches 1. So in order to do that, I'm going to multiply by the conjugate of the numerator. Man, I am not going to have, there's no way I'm going to have room to do this. So I'm going to do this on a separate sheet again. So let me just get this down really quickly. Okay, so let me switch. Okay. So I'm going to be taking the limit as x approaches 1 of this function. And in order to do that, I said I was going to multiply by the conjugate of the numerator. So I'm going to multiply both top and bottom by this. Whoops, excuse me. Okay, before I continue, are there any follow-ups on what I'm doing here or why I'm doing it? No? Okay, so let's keep on going here. So in this case, in the numerator, I'm going to get x, so the square of the first minus the square of the second. And in the denominator, it looks like I'm going to get a kind of a large mess. So I'm going to get that times this, but hopefully it's not too hard to evaluate. Okay. So in the numerator, looks like, let's clean that numerator up a bit. So it looks like I'm going to get x plus 3 minus 3x minus 1, right? All over. I was kind of hoping, maybe it will. Let's just see where this goes. Hopefully I haven't made any mistakes yet, but let's see where this goes. If I did, I'm going to check before I go too much further because something looks a little bad. So this becomes, oh no, maybe it's okay. So in the numerator, it looks like I get negative 2x plus 2 all over that denominator. And I'm going to factor out something out of that numerator here. Yeah, I definitely needed more room. So let's factor out a negative 2 out of that numerator. So I get negative 2, and that gives me x minus 1, which is perfect. Because notice I'm going to have both an x minus 1 on top and bottom, so I'm removing that 0. So these cancel out, which is exactly what I want. Then what I'm going to do is I'm going to evaluate this new function, right? I'm going to evaluate this thing right here. I don't know why I'm doing it in purple. There isn't a good reason. So I'm going to evaluate this thing right here at 1. So in this case, I'm going to get, that's a plus. What do I get? I get negative 2 over 1 plus 3 is 4, square root of 4 is 2, plus 3 plus 1 is 4, square root of 4 is 2, so I get that. So negative 2 over 4, which is negative 1/2. In regards to that one, are there any follow-ups? Kind of a long problem, but hopefully it was fairly straightforward. Okay, let's keep on moving on. And just to give you guys a heads up, I am going to jump off at 10:15 because I do have a meeting at 10:30 and it's using Zoom and I have never used it before, so it may take me a few minutes to get that set up for my meeting. So I don't have a problem with tomorrow when we do our stuff tomorrow. I will have plenty of time. There will be no time limits. So if we need to ask more multiple choice questions, anything that doesn't get answered today or it comes up, you can ask them after the normal live stream. So let's see where we are here. Let's look at, so the question is number 24 and 26. Let's do 24 and then probably wait on 26. Let's see what 26 is. Yeah, I want to wait on 26. I think this one's more of an explanation one. I remember it, kind of. So I know it's a little bit more of an explanation. So let's do number 24 and then we'll call it there for now. For now. And again, like I said, tomorrow, if you have more, we can go over it. And again, just a reminder, tomorrow's live stream will be at the normal time, 10 a.m. Okay, so let's see the average value of this function over the interval from 1 to e. So this is the average value theorem. So this is going to be, and again, I'm doing it up here. Hopefully that's okay. E minus 1 from 1 over e, and that's ln of x over x dx. Okay. Oh, I'm sorry. It says I meant 23, not 24. Okay, perfect. Let's do that then. What do we got? So for number 23, the slope field for the differential blank is given in the figure. The slope field corresponds to which of the following differential equations? Okay, so this looks a lot worse than it is. Here's what I'm going to do. So reminder, we're looking at, this is quadrant 1, this is quadrant 2, this is quadrant 3, that's hard to see, and this is quadrant 4. What I'm going to do is I'm going to just start plugging in some numbers. And so I'm gonna just start plugging things into these things. So let's see. The first thing I'm gonna do is I'm gonna erase these red things that I just did. But what happens if I plug in the first quadrant? I'm looking for things that are negative, right? All those slopes are negative. So if I were to plug in like the point 1, 1, right? Because in quadrant 1, 1, 1 is there. I think you'd agree this can't be it, because that's going to give me a positive. The second one can't be in. I plug in 1, I get a positive number. For C, if I plug in 1, I get a negative 1. Okay, so this is a possibility. And then for the next one, if I plug in 1, right, I get e to the, I get 1 over e, which is still going to be a positive number. That's not going to work. And then I get 1 minus the natural log of 1. Natural log of 1 is 0. That's a positive number. Oh, wait, did they all just disappear like that? Why did I thought there was a second one that it could have possibly been. I guess it's just this one. Why did I think there was a second one it could have been? Did I evaluate any of those incorrectly? If I plug in 1, 1, that one, the first one has to be positive, second one has to be positive, third one has to be negative. That's e, that's 1 over e. 1 over e is a positive number. No, that's the only one it could be. So maybe I'm thinking of a different question, but that's what these come down to, right? I just kind of plug in something. So let's pretend for just a second that another function had worked. So maybe quadrant 1 had, maybe there were 2 functions. Then I would have just chosen a different quadrant. And I would have said, okay, let's look at this quadrant and see between those two which one works. It's just a matter of, like I said, you're just plugging in a couple values and seeing what works. Okay, like I said, I do have a meeting and I do need to get my things set up here, which may take me a while. So I thank you all for being here today. If there's tomorrow's live stream will be at 10 a.m. We will be at that time. We will be going over, just to make sure, we will be going over this one, I'm not going to put it so you guys can see it. We're going to be going over number 8. Wait, it is number 8, right? Yeah, we'll be going over number 8. Oop. And I think that's, like I said, I think that's about, we're going to go over number 8, and I will assign another problem from the free response, and we can go over some multiple choice questions. So I think that's my only plan. Maybe I had another plan. I'll double check on my thing. But otherwise, that's what I got for you guys today. I thank you again for your time, and I am going to log off now and go to my meeting.